So next, one more important topic, which is actually an enhancement right from the Java 5 itself. Okay, there's a feature, Java language feature called generics, which is available from Java 5. Okay, so we look at the generics. Take some introduction part initially. So what is generics? Okay, now before going into exactly generics, how do we use these? Say this is more applicable to the reference type. Okay, or as far as generics is concerned, it's applicable to three kinds of things in the Java language. Okay. Okay. Fine. So only three things can be generic in Java, and that is we can have a generic class, interface, or a method. So these three generics is applicable to. So we can have a generic class, we may have a generic interface, or we may even have a generic method. Okay, fine. So when does a class become a generic class, or when does it become any of those become generic? Okay, so there is a slightly different syntax. Okay. Right. So the syntax for defining a generic class. Okay, so generic class or a generic interface, for both of them it's quite similar. Okay, so we know how we define a class, right? So in general we can define a public class. Let's give the name as generic class. Okay, I've just used the class name as generic class. So immediately following a class name, we have angular brackets in which we can give a list of identifiers, comma separated list of identifiers. Okay, someone says, oh, I have okay, let me use TP1. See, these are known as parameters, but rather than saying parameters, these are actually type parameters. We call them as type parameters. That's the reason I've just abbreviated to TP1, TP2. So what are TP1, TP2? They are simple identifiers, okay, which stand for some kind of a data type. Okay, they stand for a data type. So this is a class called generic class, which has got two type identifiers, type parameters. This has got two type parameters. Okay, there's type parameter 1, we call it as TP1. There's type parameter 2, we call it as TP2. Okay, so the idea here is, yes, you can have classes or even interfaces. When you define a class or you define an interface, you can specify a list of type parameters. They may contain a list of type parameters. Okay, from usage point of view, so if you got a class like this, or maybe I'll just make it as, instead of TP1, TP2, the normal convention here for the type parameters, the convention is to use single capital letter. For example, I might just say A and B, something like this. Use single type parameter, a single capital letter. Okay, that's a convention. It's just a convention. You find in some cases, yes, you may like to use more than one letter. It is fine, but yeah, convention is to use single capital letter. Okay, and more commonly, what are used are something like saying T. Okay, and then someone says, okay, let me call it as P. Right. Okay. Fine. The convention is single capital letter. Okay, I'll keep it as A and B. Okay, fine, because we are just trying to understand what it is. Now, what are these A and B? Same parameter like Pascal. Huh? Same parameter like Pascal. Same means? A. Oh, there are two identifiers. So there are two different identifiers. Right? We can't have two variables with the same name, right? When you define a method, right, the parameters which you are passing, each one has a distinct name. So this is A stands for the first type parameter, B stands for the second type parameter. Then we are simply saying this has got two type parameters. Okay, first one let's call it A, second one let's call it B. Okay, now only thing here is let me also explain simultaneously usage of classes and interfaces. How do we use them, classes and interfaces? They are data types. Okay, so when you use them to declare variables. First step would be declare a variable of a type. Okay, so someone says, oh, let me have a variable of type generic class. But when you mention such a thing, okay, you will have to specify, since this is a generic class, has got two type parameters, you have to specify two data types. You'll have to specify two data types. Fine. So for example, and again, this has to be referenced. Someone says, oh, let the first one be string and let the second one be someone says, okay, let me use the integer class. And then declare a variable. So I have a variable called generic GC1, let's say. Okay, so this is GC1, and I'm also having another one. So when you declare variables, and let me call GC2, but where I might change these things. So I'll say, okay, the first one is not a string, but that's my account object. That's my account class, and second one is maybe I would like to keep it long something. Okay, the idea is, yes, this has got, when someone will use these data types, okay, he has to mention two more reference types. You can't be using a int or a long, fine, you can't be using the primitive types here. Fine, primitive is not allowed. It has to be a reference type. Fine. Someone could even use something like someone says, oh, I would like to keep an int array. Yeah, that's a reference type. So this is valid. Okay, and the type parameters, so see, this is when you are defining a type as a generic, you will be putting the list of type parameters, how many parameters I need. So for someone to use the generic class, how do we use? You'll declare variable. That's the first thing. Right? So now this GC1 says, GC1 is of a type which is generic class of string comma int array. Fine, we use the word of here. See, I mentioned as, what is GC1? GC1 is generic class of string comma int array. Okay. Okay. Now, what are A and B? We understand they will be, for someone to use the generic class, someone will have to specify some data types for A and B. So A and B are type parameters. See, when we use in a method, right, they are value parameters. You have to pass a value to invoke the method. You have to pass some data according to the type which is already mentioned for the, here it is about parameterizing the type itself. Okay, the parameter is for a type. So you don't want to fix type inside the class definition. Okay, right. So for example, here I might decide to use the type parameters. I'll say, okay, let's have a private variable of type A. Okay, let me give a variable name A, or yeah, let's say, okay, and let me have another type parameter. Let's B. Okay. So we have got two type parameters. That means, see, now one more thing. This is a usage which happens later. Okay, this usage happens later. Okay, Whereas this definition is defined independent of, someone doesn't know how it's going to be used. The one who is defining this class is not aware what will be the types for A and B. Okay, fine. Now now a question arises. If somewhere, right, A and B are instance variables, okay, A and B are instance variables, you cannot use the capital A and capital B for a static type. If you have a static declaration in this, or I might have a public static, okay, and someone says, oh, let me have type A, that's invalid. And this is invalid because you see it's a variable which will be declared where you will be mentioning the type parameter. So unless there is some object, fine, these type parameters do not come into picture. Okay, so it is to be linked to an object only. Static is not related to object, therefore this is not valid. Okay, for static type you can't have a valid thing. Okay, so I can use A and B maybe for instance variables. I might use a method or maybe or even a constructor. Someone says, oh, let's have a generic class, the constructor for generic class, and it says, oh, we will have A as a parameter, fine, and we'll have another parameter, maybe a string, a third parameter is B, okay, a string S here, okay. Fine, and then of course you have your class here, fine, your class definition, whatever code may be there. Here again you might have some more variables, okay, okay, fine. Now within this, one of the things you might do is this dot x, right, this dot a, yeah, a is a variable equal to x, and this is valid because both are of type A. Whatever is the first type parameter, that is what it is. Okay, fine. This dot b equals y. Fine. You might have used that string s for some other reasons in this constructor, and we are not looking at that. Okay, my question now here is, the one who is defining this class does not know what will be A and B, what are they, what types they are. Okay, so question here is, this dot A dot, which methods can I use here? Which methods will I be able to use here? Yeah. With the return type of, no, we are invoking a method on the variable which is of type A. Which methods? On A. So A dot which? What do I know about the type of A? I can on A, find that lowercase a, I can use the methods based on whatever is the type of A. So I don't know the type of A and I can't assume anything. Do I know what is the type for A? See, when the compiler is going to compile this, right? We understand Java is a strictly typed language. Type for everything has to be known to the compiler. What will the compiler assume about the type of A? Object. Object class, any method of the object. It is treating it like an object only, because I don't know the type. Clear? You know, it is only thing known is it's a reference. It is some reference type, and therefore methods of object will be available for use here. Within the class definition, within the entire class definition of this generic class, wherever type A is there, it's like an object to me. Okay, I cannot be using any other methods other than the methods of object class. Fine, clear? Okay, fine, clear on this? For A, okay, it's only the methods of object class which will be available. Okay, how can so if someone wants to use the generic class, yes, he is not fine. For example, see what I might do here is, let's see another thing which we can do. Okay, fine. There's one more thing which we can do here. Now this is it's not an exercise for you to do it. It's for the purpose of understanding. Fine. It's not a good idea to be making the account class to be generic currently, but I'll show you the way it may have been used. Fine. And how do I raise a question? And let's try to get this. Okay. So we have this class. So we have defined this. So we are defining now. Okay. So we are again defining the class called account. Okay. So we have the class account, right? Okay. In this, we are having the private variable. What's the first variable? Account number. What should be the type for account number? Why? Huh? Why not a string? But still, I would like to keep it as a string. You can? Because am I going to do some arithmetic with the account numbers?
But आपने पास available है ना?
Huh?
Long available है.
String भी available है. So I decide, no, let it be decided by the one who wants to use the account class. The idea is that let it be decided by the one who uses the account class. What should be the type for account number? Okay, so we'll say, okay, let's have AN. Okay, and here put a AN as a type parameter. I'm not going to use anything more than, right? So other than using it like a, we're not using much for account number. What is the usage? We're simply printing it, displaying it, right? No one wants to use it for any other purpose here. Okay. And so we have the account number. Okay. So we find a reason why we are putting this here. Now, let's do a similar thing for, okay, we have the private string name. That was the second one. I kept the type for name. What about the balance? What should be the type for balance? Long. Yeah, someone says long, and then someone was saying we should use double, and someone would say, oh, let's use that big integer and the big decimal type. Someone might go for that also. Oh, it should be a number, right? But it should be a number. I don't want to declare number, but I'll make it generic. I'll make it generic. Okay. But yeah, if I have made it generic in this manner, okay, fine. Someone who wants to use the account class, now from the user's perspective, account of, what he'll declare? Okay, I want the account number to be a string type. Okay, what should be the balance type? Okay, you want it to be a float here. One thing, remember, it should be a reference type. Right? So you can say, okay, this is AC1. Okay, fine. Same way, like you thought of float, someone says, no, I want it to be a string. Who is going to stop him from using a string? Or someone says, no, I would like it to be a rectangle. Who is going to stop him? A class can have a type parameter. Once you mention a type parameter, the user is free to do anything, specify anything, the user of the class. So here, what we have here is, we have what we call as a bounded type parameter. Your type parameter for a generic class or interface can be bounded. Okay, so type parameters can be bounded. So we specify a bound by saying extends. Yeah, someone was thinking of saying number, right? Extends number. Okay, once you say extends number, and this is an example. So first one was a generic type parameter. Second one is a bound. So that's a type simple type parameter an. B is a bounded type parameter having one bound, and that bound is number. The bound is number. Okay. Now tell me, since I know about this, B is of type number, fine, it would at least be a number. It would be a subtype of number. What is known as, it is number or any subtype of number. So this usage is fine. This is good. Okay. But this one, oh, that would be an error. Okay. That would not compile now. You are preventing. So you are giving bounds to a generic class, but your bound is, sorry, you are giving type parameter to a generic class, but your type parameter is bounded. And so bounding is done with the help of keyword extends. Okay. Yeah, there are actually some interface which we should have done. Okay, so I'll take it next time, that particular interface. There is an interface called comparable. Okay, and there is one interface called comparable. And it's an interface. Now, if someone wants to use, mention here that no, it's not that it should only be number, but it should also be comparable. See, number has many subclasses. Number has got many subclasses. Okay, subclasses like float. Okay, byte, short, integer, long, float, and double. Plus big integer, big decimal. But there's something also more than this. There are a few more types called atomic int, atomic long. There are also such classes. They're all subclass of number. Okay, but one thing common to all others except for these atomic int and atomic long, others are implementing an interface called comparable. There is an interface called comparable. Comparable has some method. Okay, that means if it is comparable, that method becomes available to me. Okay, so now what I'm trying to show here is, when you specify bounds for a type parameter, you can have multiple bounds where the bounds may be classes or interfaces. Okay, but as far as classes are concerned, it can only be one class. When you mention bound for a type parameter, it can have only one class, and that should be mentioned first. You can have any number of interfaces as bounds for a type parameter. So you could be saying and comparable. Comparable is some interface type. So if it's an interface type, someone wants to also say, okay, now it's not applicable here, but just for the syntax understanding, I'm saying, okay, and I can say and. Oh, it doesn't make any sense to have a account also be in the type parameter be balance should be for type which is penalty type. No, that's not right. But anyway, it's just for syntextual understanding that yes, we can be specifying multiple bounds for a type parameter. B here has got 3 bounds: number, comparable, and penalty. It's our interface. So it is any number of interfaces. Only the first one can be a class. When only one class can be a bound for a type parameter, and at the most one class. So your bound may not have even a class. So for example, yes, extends, and you don't want to give number and you only want to give interfaces, but that's also fine. Syntax wise, fine, one class and multiple interfaces. It can be 0 class also, only interfaces. Okay, fine. So I'll restore it and say, oh, we even remove the penalty thing here. Okay, fine. So now my question here would be, this is B is a balance type. Now within this class definition, we know account number dot which methods will be available to me? Methods of object class. Whereas balance dot which methods are available to me? Methods of number as well as okay, those are the methods which are available on the type B. If it's a bounded type, only one can be a class. We understand how the bounds can be given, right? So the idea here is, if someone is going to give a type, that would be maybe it's a class, right? If the type being used is a class, fine. Okay, so you will be using a class. For example, here I might be saying account of string comma. The second one I might use big integer, okay, because big integer is extending the number class and it is also implementing the comparable interface. So whatever type you are using is something which is a subtype of both of them. Okay, if you have mentioned 3 interfaces, there is a class which implements all the 3 interfaces. Okay, bounds can be any number of interfaces. Then what you pass as a type parameter, the data type which you specify, has to be a type which is implementing all of them. Okay, and therefore on that object, fine, on this object I can use all the methods of the bounds. Methods of bounds will become available. Okay, fine. So you have a bounded type parameter. Okay, so bounds, okay, we have type parameters applicable to class. Type parameters are also applicable to a interface. Okay, so if I have to have a generic interface, yeah, public interface. Okay, so you have a public interface, generic interface, and yeah, it is a generic one, so I can have type parameter 1 comma TP2, okay, something like this. Whatever the numbers needed, okay. I'm showing only 2, but you might say 3, 4, 5, whatever, any number, 0, 1, 2, 3, 4, not 0, but 1, 2, 3, 4, okay, fine. So within the body, yes, when you define a method, a return type, wherever type is available, right, wherever you can use a type, you can use them as, you don't want to fix the type, okay, let it be in terms of TP1 or in terms of TP2, fine. Okay, now talking about methods, right? So yeah, methods would be inside a class or inside some place. They would be static or default, or maybe they are the normal methods, whatever the instance methods. Okay, inside an interface, it may be a default method. So when I have a method, so I'm just talking about method, okay, public. I'm just taking only as an example, the return type is, okay, some return type is there. Yeah. Now, before a return type, you mention the type parameter. So you have some modifiers. If it is static, yes, the static, and even the final. If it is final, maybe public and final. So any modifiers will come before the list of type parameters for a generic method. Okay. Fine. Okay, maybe it is static, and here I'll say, okay, so this has type parameter 1, type parameter 2, type parameter 3, okay, and then we have the return type. Yeah, so here is the whatever is the return type, and then is the method name. So let me call it as generic method, and yeah, okay. So within this, yes, these TP1, TP2, TP3, they are data types. Some types. Again, like we have seen earlier, these also can have bounds. So anytime, wherever we have a type parameter list, you can have a bounded type parameter. So type parameter may be a simple one, or it may be a bounded. And so we can have bounded type parameters. So classes, interfaces, and methods can have type parameters. For classes and interfaces, okay, when you are defining them, right? Fine. We put the list of type parameters immediately following the name. Whereas for method, immediately preceding the return type. Fine. Just before the return type, you have a list of type parameters. A type parameter may be normal or it may be bounded. Okay. Okay. And so this is just an initial idea of generic types. And we'll be looking at it more. Okay. But before we proceed, fine, there is also some, there are, so that we can have sufficient examples, we will have a look at a couple of interfaces. There are a couple of interfaces which are interesting. So we have these, fine, we haven't looked at many interfaces yet. So from the library, there are interfaces called comparable and comparator. Okay, so we'll look at these two things first. Okay, right. So our next thing would be about comparable and comparator interfaces, and then we may look at few more things in generic. Okay, and so next would be about the comparable and comparator interfaces. For just a little, just a small point related to comparable and comparator. We know about the comparison operators. What were the operators? Comparison operators? Yeah. They were nothing but, yeah, less than, greater than, less than, equal to, right? Greater than, equal to. Fine. Equal to and not equal to. Yeah. Okay. Equal to, we know what is equal to. For no, see, these operators, we know they are very nicely available for the primitives. Huh? No. Double equal to is not assignment, it's a comparison, whether it is equal or not. Okay, fine. This for primitive types, fine, we understand. See, if I put a not equal to, that means it is in terms of opposite of double equal to. Okay, fine. But one thing to understand here is that these comparison operators, okay, when we work with them, they work for primitives. What about reference type? For reference type, we know something related to double equal to, equals method. Fine. Equals method is what is available for reference type. Fine. Double equal to. Fine. Double equal to, equivalent thing for a reference type would be use the equals method. You want to know about equality. Fine. Okay. Fine. Now think of comparison. Less than, greater than. When we talk of less than, greater than, it has to be some kind of a quantity. Right? We make comparison of numeric values. Okay. But do we compare other things as well? Reference type. Okay. That's where the comparable and comparator will fit. Okay. They'll come into picture. Fine. So anyway, we'll continue tomorrow. And any questions you have so far? Yeah. Any questions? Yeah. Okay, fine. Then we continue tomorrow.